Boom, C3PO. This is a smart bin that I have managed to create with my bare hands and the help of a couple of tools. That is right, a smart bin that cost me under $20. The basic elements of this DIY smart device are the motor, sensor, the bin itself, and of course the star of the show, the Arduino microcontroller. The bin's main purpose is to automatically open. I've set its sensors to determine when an object is within 30 centimeters distance. Super nifty when you don't actually want to touch a bin, and also it's a great place to start with any DIY electronics for any beginner. You don't need anything fancy. This is actually my first Arduino project. Literally anyone can do this. First, you'll want to make sure you have a few different tools and equipment. Then we're going to go through different stages together. We're going to do the basic setup. Then we're going to do the wiring, the programming, the testing, and the most exciting part, the final assemble. When it comes to costs, I really recommend shopping around. You can buy a lot of the stuff we're going to use today about 3 times cheaper on various online platforms. I will be using an Arduino Nano for this project, although you could use an Ethernet Arduino if you want something a little bigger and a little less fiddly. I will also use a breadboard with my Arduino. With breadboards, each column on the end is either plus or minus, and they are joined vertically. Then the inner breadboard is connected horizontally. So you just want to take your Arduino and stick it at the bottom, just in the center. If you're wondering, Arduino is basically a software company that is open source and manufactures single board microcontrollers. Arduino is made up of 2 parts. You've got the hardware and then the software. Essentially, it's a little computer on a chip with a circuit board and input and output connections. Moving on to the next part, the wiring. There are 3 components that need to be wired. You've got the breadboard, the motor, the sensor, and then the USB needs to be connected to a power source. Funnily enough, Arduino all started out as a research project and today is used far and wide for educational purposes, to replicating the awesome jetpack from the hit Disney Plus show Mandalorian. That is why it is used in thousands of projects and applications. It's even compatible with Mac, Windows, and Linux. So first I'm going to wire the Arduino to the breadboard. I will take this one and I will put it into ground. Then I will take this and put it into negative, into minus. Next you want to take this orange cable and put it into 5 volts. So 5V. And you want to put it into the opposite, so into plus. So what this means is we're taking the power from Arduino and putting it into the breadboard, so everything on here will have power. So now I've taken my sensor and it's wired, as you can see here, and we just want to wire it to our breadboard. So I will take the red wire and put it onto any plus, and I will take the black wire and put it onto any negative. Like that, should look like this. So now I'm going to wire the echo and trigger wires. I'll take this green one and put it to 28. And I will take the yellow one and put it to 27. And the reason that we've put these here is because in our code we've determined 28 and 27. You can alter those. Now we have our servo motor, and what we're going to do with this is we're going to again wire it. We'll take the red to the plus. You want to take the black to the minus. And you want to take control wire to 23 because that's determined in our programming, in our software. But again, it will be different for you. You can change that along the way, like so. Okay, so now that everything is wired, you want to take the USB and connect it to some power source. We're going to plug it into my computer. I've downloaded, oh, it's going already. I've already downloaded the Arduino IDE software for my computer, my specific one, and I have taken some example codes. There's loads, you need to find the right ones for what you want to do, for your motor and for your sensor. We put them onto the same document, which is here, and it's important to use this little tick here to verify your code. So here is my code, and in this case we have trigger distance and it is at 30 centimeters right now. What this means is with my sensor, when anything comes within a 30 centimeter distance, our bin hopefully will open. Okay, so as we said, we set our trigger distance to 30 centimeters. I've got a ruler here, and I have our sensor at the other end of the ruler. And let's do a little testing. The motor should go off when I reach 30 centimeters and beyond. So there you go. It's going. Let's try again. And it's working. The sensor here is picking up within 30 centimeters. This part is of course optional, but we're going to give this bin a facelift today. When I started this short adventure, I wasn't really sure what the outcome would be, but I've got to be honest, I'm pretty happy. I've got my own little robot doing the work for me. Boom, C3PO. Anyway, let us know down in the comments your thoughts and feelings. Let us know if you are going to build one of your own, any exciting projects you've got in the up and coming future. Please subscribe to support us and like this video, and we will see you in the next one. Bye.